Okay, so now for the short direction or in short direction. So the moment or the area of consideration for getting the MU is this one. Okay, so if this is 0.6, this is 3.2, and this is 4.8. Okay, so this one is equal to 3.2 minus 6, or 3.2 minus 0.6 divided by 2. So this is equivalent to 1.3. So 1.3. So for MU is QU, the intensity, multiplied by 1.3 multiplied by 4.8, and then multiply by the moment arm. Okay, so QU is 266.327 times 1.3 times 4.8 times 1.3 over 2. So MU is equal to 1080.22 kilonewton meter. Then check again if the section is in tension controlled or transition. So again, we need to compare phi MNT to MU. So phi MNT is 459 divided by 1.16 beta 1 fc prime b d squared multiplied by 1 minus 3 over 16 beta 1. So 459 divided by 16, beta 1 is 0.85, then 28 multiplied by 4,800 multiplied by our D. So our D in the short direction is equal to 637.5 squared, then multiply by 1 minus 3 over 16 multiplied by 0.85. Okay, so our phi MNT is equal to 11,196. So times 10 raised to, in kilonewton meter. Okay, kilonewton meter. Okay, so this is greater than the MU. So again, this one is under tension control. Phi here is 0.9. So get the value of Rn from MU is equal to phi Rn Vd squared. So MU is 1080.22. So times 10 raised to 6 to convert it to Newton millimeter, times 10 raised to 6. So it's equal to 0.9, and Rn, our B is 4,800, and our D is 637.5 squared. So Rn is equal to 0.615. Then solve for rho. So rho is equal to 0.85 fc prime. Fc prime is 28, and then Fy is over Fy 345, multiply by 1 minus square root of 1 minus 2, and then multiply by Rn divided by 0.85 FC prime. So the answer is for rho is 0.00181. Then get the rho minimum, then check if rho is less than rho minimum. So 1.4 over Fy 345. So same with the along long direction. So this is equivalent to 0.0406. So compare this to, so rho minimum governs. So use rho is equal to 0.0406. And then again AS, rho BD. So 0.00406 multiply by 4,800 multiply by 637.5. Okay. So it is equal to 12,423.6 millimeter squared. So in rectangular footing, so reinforcement in short direction shall be distributed in accordance with the section 413.3.3b. So we need to get the gamma S, then gamma S multiply it by AS, and then afterwards check the get the number of rebar for center bandwidth and for each outer bandwidth. So for the computation of gamma S, it is equal to 2 over beta plus 1. So beta is simply long direction or long side of footing, or L divided by short side divided by B. So simply 4.8 divided by 3.2. Okay, so gamma S is equal to, okay, so gamma S is equal to 2 over beta is equal to 1.5. So 1.5 plus 1 is 2.5. So gamma S is equal to 0.8. So meaning 80% of the AS is layout at the center bandwidth. So 80%, so 0.8. So AS at center band is equal to 0.8 of AS. 0.8 or 12,423.6. $9,938.88. And then for outer band, so each AS at outer bandwidth okay, so 1 minus 0.8 multiplied by 12,423.6, or simply AS minus this value. Okay, so 12,403.6 times 0.2, 2,484.72. So this one is in millimeter squared. So gamma S is unitless. So for center bandwidth, okay, our N is equal to 9,938.88 divided by the required diameter or area of rebar. So this one is equal 20.24. So let's say 21 pieces. Okay, so check for the maximum spacing of the rebar. So S provided. Okay, so S provided is equal to 3,200 divided by N minus 1. So 21 minus 1. So this one is the center band. So same with our B. Okay, B width. Okay, so 32 divided by 21 minus 1. So it is equal to 160 millimeter. So compare it with our S max. So S max, governing S max is 450 millimeter. So okay. Then therefore, so use 21 pieces, 25 mm diameter main bar, space uniformly on center at center band. And then for each outer band, so our N here is area of steel outer bandwidth 2,484.72 divided by pi over 4, 25 squared. So this time our N is equal to 5.0618. So say 6. So for each outer band, so kailangan nating hatiin sa dalawa yung number of rebar. Okay, so if this the footing, so this is the center bandwidth. So provided here 21 pieces, then here 3 pieces, then 3 pieces for each outer bandwidth. Okay, so check the maximum spacing for bars. So again, as provided is equal to, so the length of this one is, if this is 3.2 and then 3.2, this one is 4.8, so this one is 4.8 minus 3.2, okay, divided by 2, so 0.8 each outer band. Okay, so 800 millimeters, so 800 millimeters, then 1 cc or clear cover, okay, 75 minus half of the diameter of rebar divided by 3. Okay, so 3, then it is equal to 356.25. So S max again is 450 governing, so it is less than S max. Okay, so again, okay, the spacing is okay. So therefore, use 3 pieces, 25 mm, main bar, space uniformly, or uniformly on center at each outer band width. Okay, so now I will leave to you the checking of development length, yung LD natin, and then yung LDC, also yung ating B, BN and BU compared to BU, also yung LSC. Okay, compression splice. Okay, lap splice. Okay, so same lang yung procedure from our previous video. Okay, so I will now draw the detail of the footing. So let's say this one is the column, and then this one is the width, the length. Okay, then the center band width here, then the number of the number of bar. Okay, so the detail natin dito, example lang to, so hindi scaled or paresyo number of dun sa detail natin. Okay, so yan. Okay, so center band width, or the outer outer band is 0.8, and then this one is also 0.8, and the center band is 3.2, also 3.2, then 4.8 meters. Then okay, so this portion, so let's say okay, so you can note here that you have 21 pieces of 21 mm diameter transverse bar, spaced uniformly on center at center bandwidth, and 3 pieces of 25 mm diameter bar, transverse bars, spaced uniformly on center, so at each outer band width. Okay, So for our longitudinal or along short or long direction, so ito siya. So yung na-compute natin dyan is equal to, let's say, yan, yun na lang. So yung bilang, hindi naman exact, hindi ko na inexacto. Okay, so for short longitudinal bars, 21 pieces, 25 mm diameter. Okay. Longitudinal bar, okay, space uniformly at center. On center. Okay, so yun yung tsura nya. Then yung splicing, yan, kayo na lang yung mag-compute. And then elevation, so the thickness of this is 750, okay, 75.75. Then this one is 1.8. Then the width is, let's say the width is 3.2. Yan, you can use that. Sorry, align na lang natin. So ito na lang yung 4.8. Then we have here the center bandwidth. Yan, lagay nyo na lang yung number of transverse bar, 21 yan. And 21 pieces, 25 mm. And then tatlo. Yan. So 3 pieces of 25 mm. And then yung papunta dun. Okay. So yan. So 21 pieces din. Okay. So that will be our detail for our rectangular footing. So thank you.